Hello and welcome. My name is Tokebi Games. I am a former Roblox engineer, and I will be teaching you how to develop game mechanics. If you're enjoying this content and learning something new, take a second to hit the like button and subscribe to the channel. It really helps me keep making videos like this and keeps you updated when new tutorials drop. In my previous videos, I showed you how to create a loot drop system and a scalable tool system. If you haven't watched those yet, you can find the links in the description. Today, we're building a resource gathering system that integrates seamlessly with both the tool and loot drop systems. I was playing Ark Survival Evolved, gathering resources in the wild, and it hit me. Building a resource gathering system like the one in Ark is the perfect next step. Since we already have a loot drop system and a tool system, this ties everything together. You can use this setup in any survival game, RPG, or simulator. Here's the final system in action. As you can see, I can gather resources from different objects in the workspace, and each one drops its own unique loot. Now, I'll walk you through how this system was built step by step, and more importantly, how easy it is to add new tools, resource nodes, or loot types. Whether you're building a survival game, RPG, or simulator, this system is designed to be flexible and scalable. All right, the first thing we need to do is copy all the files from the loot system and the tool system into one project file. If you've done that correctly, here's what you should see. Under Starter Guy, you'll find a Do Not Reset GUI with a script called Create Loot inside. You should also see a Tools Guy that contains the local tools script. Now in Server Script Service, there should be 3 scripts: player leaving, tools, and loot module. Don't worry about player leaving for now. It's not important for this tutorial. In Replicated Storage, you should see 5 folders: Loot, Aches Loot Commons, Remote Events, Remote Functions, and Tool Remotes. Each one has the remote events or functions it needs for the system to work. Over in Server Storage, there should be a Tool Animations folder with 1 animation, and a Tool Sounds folder with 2 sound effects. And finally, in Starter Pack, you should see 2 tools, the Axe tool and the Pickaxe. Once you have all that in place, you're ready to build on top of it. Let's go back to our Tools script under Server Script Service. As you may remember, this is where we have the Loot Maker and Generate Loot functions. We're going to make a small change to the highlighted lines. Just a minor adjustment, but an important one. This change corrects an oversight on my part. Originally, the loot table was composed of object references, but we're going to switch that to use strings instead. Why? Because in many cases, we'll want to pass in predefined loot, and using text makes that process much more flexible and efficient. After this update, your functions should look like this. It's a small tweak, but one that makes the system much more scalable and powerful down the line. In the same script, we have the assign loot function. I didn't include this in the original system since it wasn't the main objective, but for this demo, we'll use it to store the collected items in a dictionary, just to show you how that can be done. After you finish coding the function, it should look like this. It's not very complicated. It checks if the player's name exists in the dictionary. If it doesn't, it adds it. Then it checks if the item exists under that player's data. If it doesn't, it creates it. And if it does, it increases the count. The dictionary itself is declared at the top of the script, globally, as you can see here. And with that, we're done updating this script. Now we're ready to move on to the next step. Now go back into the starter pack and select any of the tools. We're going to add 2 new attributes: damage, which is a number, and type, which is a string. The type attribute is especially important because it lets us group tools by category. For example, you can have multiple kinds of axes, but as long as they share the same type, you won't need to write separate logic for each one. Make sure to repeat this process for any other tool you have in your game. It'll all make more sense once we start tying it together, I promise. Now let's go into our workspace and insert a few items that we can mine. I forgot to mention it earlier, but make sure you also have local sounds and loot folder in your workspace. Now, back to the items we inserted, let's click on one of the rocks. After selecting the object, go to the tag section and tag it as minable, and also add the tool it can be mined with, in this case, Pickaxe. Next, add 4 attributes: Health and max health are both numeric and work similarly to how health and max health work for humanoids. Respawn is also numeric. This represents the number of seconds before the item reappears after being mined. I've set it to 15. Lastly, add a loot attribute, which is a string. Here you'll enter the name of the loot you want to drop. Make sure it's comma separated with no spaces. In this example, I've added rock 3 times because I want 3 rocks to drop. Now for the trees. Since they're models, expand the model and select the trunk, then repeat the same process. Tag it as minable, set the appropriate tool tag, probably axe unless you want it mined with a pickaxe, and add the same 4 attributes. Let's go back to our tool script under Server Script Service. As you may remember, the actual tools logic wasn't implemented in the previous system. This part of the code is responsible for applying damage, whether that means destroying a rock, chopping down a tree, or defeating an enemy. So let's go ahead and implement it. After just a few lines of code, here's what has changed. Now that each tool has its type defined as an attribute, we can extract that type and check if the item we're interacting with is tagged accordingly. If it is, we check whether it has a health attribute, retrieve the tool's damage, and then calculate the new health by subtracting the damage. That's it. It's that simple. Let's take a look at what we've accomplished so far. I'm selecting the gold rock in the workspace and scrolling down to its attributes. As I hit the rock with the pickaxe, you'll notice the health attribute decreases in real time. But when I switch to the axe and try the same thing, nothing happens. That's because the object isn't tagged to interact with this type of tool. Starting to see how it all fits together? Now, the next step is to handle loot drops when an object's health reaches 0. Let's dive into that. Under Server Script Service, let's add a new script and name it minable. This script will handle the logic for what happens when a minable object's health reaches 0. Let's walk through how this script is built and how it ties into the rest of the system. Inside the minable script, we'll start by requiring collection service to access all objects tagged as minable. And we'll also require the loot module, just like we did with the enemies in the loot system video. Then, we define a function that loops through all minable objects and sets up a listener for changes to their health attribute. Within this listener, we check if the object's health has reached 0 and if it hasn't already been flagged as mined. A Boolean we use to avoid running the logic multiple times. Once those conditions are met, we flag the object as mined, grab the loot attribute, the comma-separated string we previously added, and convert it into a list. We then loop over the players in the game and generate loot using the same method from our loot drop system. Finally, we apply a simple form of object pooling. We remove the object from the workspace and schedule it to return after the specified respawn time has passed. This helps us keep the system efficient and responsive. Let's see how this system behaves with multiple players. Right now, if player 1 finishes mining an object, player 2 also receives the loot, which isn't very fair, since they didn't contribute to mining the object. Fortunately, there's a quick and easy way to fix this, and that's exactly what we'll do next. First, let's go back into our tools script one more time and add the following lines of code. These lines will tag the object you're mining with your player name, and remove the tag once the mining action is complete. This way, we can keep track of all players who contributed to mining the object and ensure that only those players receive the loot. As you can see, when I hit the gold rock, my name appears under the tags and is automatically removed once the mining action is complete. Now back under Server Script Service, open the minable script again. Here, we'll add a line of code to check that the player is actually tagged on the minable object before generating the loot. This ensures that only players who contributed to the mining receive rewards. Adding a new minable item and tool is simple. Just create the tool with its appropriate tags and attributes, define the loot item with its attributes, and place the minable object in the workspace with the correct tags and attributes. That's all it takes to expand the system. As you can see, expanding the system works seamlessly and required minimal effort. If you check the output window, you'll notice the implementation we added earlier is tracking and displaying the items being collected. You can have access to this file by following the link in the description to my GitHub repository. Also, please join my community on Roblox, Tokebi Academy, where you can have access to the demos and collaborate with me. If you have not done it yet, please take a minute to subscribe and like this video, as this will greatly help me to continue making this type of content. Thanks for watching, and hope to see your comments and suggestions.